Today, we're going to start lines that intersect circles, section 11.1. So we're talking about circles. Chapter 11 is all about circles, all the special things that go into circles. And today we're talking about just some of the lines that intersect circles, some of the special parts of circles. If you look up on the walls, there are two posters over here that both deal with circles. Those are both the two things that we're going to be talking about this whole chapter. So again, if you sit on the right side of the room, you're lucky.
Yeah, I used to sit over there. Always on there. I used to sit over there, but...
Sorry, man.
Now.
So, circles here. Circles. Oh, hey, it's in front of the room, too. Look at that.
Yeah.
Front left. Right there. Lines and segments that intersect circles. The three things we're going to talk about today are a chord, a secant, and a tangent. A chord is a segment whose endpoints lie on a circle. Notice AB here. That is a chord. AB is anything that ends the two endpoints are on the circle. It doesn't have to be, go across the middle. It doesn't have to go anywhere special. Okay? It's just a segment that has two endpoints on the circle. A secant. A secant is a line that intersects a circle at 2 points. Notice, a secant. What's the main difference between a secant and a chord? A secant goes all the way through and it keeps extending both sides. A chord just kind of stops there. A tangent is a line in the same plane as the circle that intersects the circle at exactly 1 point, called the point of tangency. Notice, E, that is a tangent line. So if you look at the three, there's three differences. A chord stops on the circles. A secant intersects twice, it goes through the circle. A tangent is on the outside of the circle. Okay? A little bit. Tangent circles. Tangent circles are two coplanar circles that intersect at exactly 1 point, and they're called tangent circles. So notice, tangent circles intersect at one location there, and that location is called the point of tangency. Okay, those are tangent circles. So, lines and circles here. For exercise 1 through 5, match the letter of the part of the circles to the names. Use each letter once. So number 1 here, I want to find a chord. Where is a chord in that? What do you say, Drew? What? Yeah. DE is a chord. Nice job. Yeah, E goes right there. DE right there, that'd be an example of a chord. What about a tangent? Which one's a tangent, Nick? Yeah, line L is a tangent line right there. What about a radius? Which one would be a radius up there, Bryce? AB. Yeah, AB is the radius. And then we have a secant. Which one's the secant? Well, what do you say, Johnny? Yeah, line M is the secant. And then diameter. Which one is the diameter have to be, Gabe? BC is my diameter. Nice job. So those are kind of the 5 parts of circles that we're going to talk about here. Using that information, take a couple seconds, try number 6 and 7 on your own. Identify each line or segment that intersects each circle. So you should have 3 answers. If you wanted to kind of be more specific, you could on some of those. But identify the parts in the 2 circles they give you. All right, number 6. What's something you notice in number 6? What do you say, Johnny?
M is tangent.
Yeah, M here is the tangent line. What's something you notice, Jack? Yeah, GH here, that'd be called a radius. What else do you notice in here, T-Roy? FG there, that's the diameter. And what else you got, Drew? L would be the secant. What about number 7 here? What do you notice in number 7, Tina? The what? This is the radius. What about you, Trev? What do you notice? LM is the secant. And Payne, what about you? What? No, we have one more. Tangent, thank you. Yeah, MN is tangent right there. Good job. Alright, so using that information here, let's try and find some tangent lines. So number 8 asks us, find the radius of circle P and the radius of circle Q. So as you look at the circles there, what is the radius of circle P going to be, T-Roy? 2. What's the radius of circle Q going to be, Jessica? 1. So I want to know the coordinates of the point of tangency. So as you look here, what are the coordinates of that point of tangency, Caitlin? It is 4, 2. Okay, great. So that's the point of tangency, the point where the circles kind of intersect there. Number 10 says the equation of the tangent line of the point of tangency. So what's the equation of this line going right through there, Troy? Yeah, it's x equals 4. Why is the x equals, Troy? Yeah, it's a vertical line. Anytime we have a vertical line, that's where we get x equals. If I were to have a horizontal line, what do we call that? Y equals. Horizontal lines are y equals. Nice job. So using that information, take a couple seconds, try numbers 11 and 12. Find the radius of all the circles. Identify the point of tangency, and then write the equation of the tangent line. Take a couple seconds and try these. Number 11. True. What's the radius of circle N, Gabe? The circle N, radius. Radius can be negative, sir. 3. Because the radius from the center to the circle, 3. P, what's the radius of P, Johnny? 1. Now I need to find the point of tangency. Where's the point of tangency, Nick? -1, -2. And then I need to write the equation of that line. Camden, what's the equation of that line? Y equals -2. And notice it's y equals because we have a horizontal line. Number 12. What's the radius of S? Hannah, what's the radius of S? Hannah? The radius of S? It's actually 4. And T has a radius of what, Tyler? 2. Where's my point of tangency located, Caitlin? What? Point of tangency, where's that located at? 7, 0.
I get it.
And then I need the equation of that line. And what's the equation of that line, K? X equals 7. No, you just did. You just did. And then the last thing we're going to talk about here is tangent lines. Well, something special about tangent lines. If two segments are tangent to a circle from the same external point, then the segments are congruent. So what that means here, if they're tangent and then meet at the same point, they are then congruent. Okay? So in the figure above, EF equals 2y, and EG equals y plus 8. Well, if I want to solve for y, what are you supposed to have to do with those two segments? I have to set them equal to each other, and then I solve. Okay, so that's kind of unique. So let's look at number 13 here. In exercises 13 and 14, GH and GI are tangent to circle J. Find GH. Well, I know GH is 2x. I know GI is x plus 12. So what do I have to do with those two segments then? I set them equal to each other. So I say 2x equals x plus 12. So 2x equals x plus 12. How would I solve this then? Noah, what would you do?
You subtract x from 2x and then x equals 12.
And then the question is find GH. So what do you do with that 12? You would? And what do you get then?
24.
Nice job. But then what about number 14? I have GH is x plus 10, GI is 2x minus 1. What would I do there, Bryce?
Subtract x, subtract 2x and x, and then add 1.
Correct. First thing to do is set equal to each other though first, right?
Yeah.
And then, yeah, subtract the x over. Add the 1 over. You end up with x equals 11. You take 11, plug it in for our x, and what do you get for GH to be? Anybody? 21. Nice job. Oops, wrong one. Wait, no, 15, 16. Yep. Take a couple seconds, try numbers 15, 16 on your own. There we go. Number 15. What did you have to do on number 15, Johnny?
You said equal.
Set them equal to each other, so you had 2x equals x plus 3. What did you get x to equal, Johnny?
6. Or, 3, and then
Then you plug it back in, and what do each of them have to be then?
6.
6. Nice job. 16. What do you have to do first, Gabe?
7 equal.
So you get 2y minus 2 equals y plus 6. Set them equal to each other, and then what would you do? Solve, and you get y equals what?
Y equals 4.
Yeah, there's seriously no callbacks.
But it's y equals what? 8. And then I plug that back in, you get what for answers? They're all 14. Take a couple seconds, try numbers 17 and 18. No. 17. What did you get y to equal, Troy?
Y equal 2.
So then you plug it back in, what do you get for answer then, sir? 10. And number 18. What did you get x to equal, Caprio?
7.
And you plug it back in, what do you get, sir?
Is 19.
19, nice job.
You used the
Here is your assignment.